Hi everyone. Leetcode weekly canvas 514. Minimum total price after applying discounts. Here are given two integer arrays prices and discounts. Value prices represents of price and discounts represent discount percentage. You may apply discounts subject to following rules. Each discount can be applied to at most one item. Each item can receive at most one discount. Each item may also receive no discount. Okay. Final price is not rounded. Uh, so basically you sort You sort the prices. Okay. And you sort the discounts. Here we have our answer. Um, if I is greater than m, answer plus equal to price is I times 100, else answer plus equal to price is I times 100 minus discount is I. So that's our answer. Return should be double answer divided by 100. 32.5, 92, and 3. Um, um, let's keep going. Weighted sum of a tree. You're given an integer array parent of length n representing a rooted tree with nodes labeled from 0 to n minus 1. The tree is rooted at node 0, so parent is 0 is equal to negative 1 for each node I, where I is between 1 and n minus 1. Parent I denotes the parent of node I. We have nums, where it's the value of node I. So we have the weight. Um, you want the sum of the weights. Okay. You can just use DFS. H is the height. Print DFS. Okay. Print X adjacency curve. D next equals D curve plus 1. DFS next. int h will be equal to max element of d. Answer plus equal to 1 long times nums I times h minus bi plus 1, return answer. 37, 20. Alright. Maximum area of two non-overlapping square matrices. 2D integer matrix map of size m times n, where map RC equals 1 means the cell at row R and column C is usable. Equals 0 means it's not usable. Your task is to find two submatrices that satisfy the following conditions. They must be squares, and they don't overlap, and they're only usable. Okay. Turn the maximum possible area. Okay. M and N are all the way to 500. So this is, I remember seeing a problem really similar to this. The int n equals mat dot size. The m equals mat 0 dot size. We're gonna make a prefix. I 3 minus 1 plus I minus 1 minus plus I minus 1 j minus 1 plus mat I minus 1 j minus 1. Okay, so this is our size. Smaller than equal to min and n. Okay. So we want to choose two submatrices, so that they don't overlap. I'm thinking greedy, so we just greedily choose, greedily choose it. So let's get this one. Queries. Its length is at least 3. Their existing is k, such that, yeah. Process, queries of two types. Calculate within nums out to R and update. Generate answer where answer I is the answer to the ith query of type 1 in the order they appear. It's up to 10 to the 5. Okay. Yeah, Q4 is pretty hard. Check if a matrix can be split into contains two. Check if a grid contains two small square grids such that all numbers in these small grids are one. So, resize. So that's n squared already. I have a 500 to the fourth power solution. We could binary search that thing, and then 500 cubed. Let's see, 500 cubed. 1, 2, 3, 4, 5, 6, 7, 8 times about 9. So that would be too much. Yeah. Q4, I think, is you can use a signature for this. Okay, so let's say what you need in a seg tree. You need your answer, first of all. You need your ref, and you need your stuff. Yeah, that's good enough. Ref, ref increase. You want them to increase, increase. Or you have to either increase or decrease. So we have a bunch of decreasing pairs. And then we add this one in there. 8.ref2. And then 7 change to 0. Position 1 put in position 4. Position 1, position 3. So you have a bunch of indices. So 1 and 3 then becomes just 1. And then you use your 4, so it becomes 1 and 3 at the end. So answer's 10 minus 3. So this is working. 友谊。 1 and 0. Is the answer in your range? 5 expected 4. Right. I did not expect to solve that problem. Uh, that was really nice, I think. Yeah, that was a really nice problem. Right. Let's go over solutions. So Q1. Okay, so for this problem, it's a greedy algorithm. So basically, it's always better to give higher discounts to items with higher prices. So it can just sort the prices in decreasing order, sort the discounts in decreasing order, and just iterate over the prices and try to give the discount to this price. If we run out of discounts and we just add prices I times 100, Otherwise, we add prices I times 100 minus discounts I. In the end, we return answer divided by 100 as a double. So pretty simple, greedy. Um, it's just always better to give higher discounts to higher price items, right? Because you get to save more. Okay. Q2. Q2 is just basically just a DFS on tree. Um, so problem says you have a tree, and then every node you have a value for it, and then you want to find a sum of all of these values. So what you can do here, since you're given the parent array, you can first construct an adjacency list. So you have ADJ parent I dot pushback I, and then you can use a DFS to find to find the depths of the nodes. This is simple. You have your int current, int next, int adjacency current. The depth of the next will be equal to depth of the current plus one, right? Because you're going deeper in the tree. So you add one to your current depth, and then you DFS your next. And then you can DFS from the node, from the root. And then you have your answer is 0. You have the total height of the tree. It should be the maximum of all of these depths. And then you just iterate through every node and then just plug in the formula, nums I times h minus d plus 1. And then you add them to answer, and you return answer. Q3. Okay. So, this problem over here. Okay. So, what we do here, we start by looking at map. Um, Basically, we do a binary search on the largest size. So, for example, over here, we can binary search between 0 and 3. Or for the side length, we have this binary search. L is 0, R is just the minimum of N and M. While L is less than R, we just do a binary search. We take the middle. We check if it's valid. And then in the end, return L times L. So basically, what this means, we just have to fill in the valid one. We're looking for n times m, so we have our size. So what I found was all we have to look at is the indices of the top values. For example, over here, these two grids, we can just write them as 0, 0 and 1, comma 2. Right over here, this can be written as 0, comma 1 and 1, comma 0. For example, this 2 by 2 would just be 0, comma 1, and we get 1, 1, 1, 1. So in order for the size to be valid, right? Notice for a 2 by 2, we have 0, 0, 0, 1, and 1, comma 2. So the reason this works is because 0, 0, it only after we add size, so it accounts for this much. We can just draw a line over here. We can separate them into two separate spaces. And one of the spaces has this grid, the other one has this grid. So all you have to do is you check the minimum of the x and the maximum of the x, and the minimum of the y and the maximum of the y. And in the end, if the minimum of x plus size is less than or equal to minimum x, but the maximum x, that means we can cut a vertical line to split it into two different sections, and those sections we know they will never overlap. Right, turn true. Same thing with y, right? If min y plus size is less than or equal to max y, we can also return true, because this means we can cut it horizontally. So just basically, now it becomes pretty easy. You can just use a prefix sums. Um, you check using prefix sums, I and j, you find the current sum in this subgrid. If the current sum equals size times size, you can just update everything and you return whatever you need to return. Okay. Next up is Q4. Okay. So Q4 is a pretty good problem. It's a segment tree. Well, I could say segment tree. I don't know if that's the intended solution, but um, so I'm gonna explain the problem really quick. Um, I'm gonna try to spend longer. So first, you know that you're given queries, right? So when I look at the queries, the first thing I think of is it a segment tree or some other range queries. So I construct the array peak. What does this mean is if peak if peak I is true or peak I is one, that just means that index I is a peak of the entire array. Right, so this is simple. This is easy to do. Just look for every I from 1 to n minus 2 if it's the maximum of its neighbors. And then you set this to 1. And then you create this segment tree. I'll go over segment tree details later. For now, just right here. So seg tree seg.init n, and seg.build peak. So you build this segment tree using this array. Now, what does the segment tree store? At the segment tree, what I did was I stored the current answer. Um, Prefix, that's all zeros. The length of the prefix, that's all zeros. The length of the suffix, that's all zeros. The first occurrence, the latest occurrence of one, and the first occurrence of one, and the size. I think these can be simplified. Um, Pref and suff and max one and min one are basically the same thing, but it's okay. Right? You can this simplifies things a tiny bit. Um, and then when we get a value x, right, we should add pref, suff, and size all to one. And then if it's x is equal to one, then max one equals zero and min one equals zero. And then whenever we get to a query, if it's a answer query, right? If we're asked to answer something, then you can just push back seg.query v1 v2 plus 1 by answer. I use LR with L inclusive and R not inclusive. Otherwise, so this is the update part. The only values you have to update are v of 1, v1 minus 1, and v1 plus 1. Because once you change v of 1, v1 minus 1 might not be a peak anymore, right? v1 plus 1 might not be a peak anymore, and v1 might become a peak or not become a peak, right? A bunch of things can change. So you only have to look at those three. Basically, what I do over here. For the first one, you check if v2 is now a peak. You just update that. For this one is v1 minus 1, right? Same thing. And this is v1 plus 1. And in the end, you set nums v1 equals v2. You can return answer. So now that's all that's left is checking the seg tree. Basically the merge part, which is going to be the most complicated part. So you have a couple of things you need, right? You need the new answer. You need the new prefix. You need the new suffix, the new max one, the new min one, and the new size. So all of them are pretty easy except for the new answer. Right. For the pref, you can just use this. If a.pref is not equal to a.size, then you return a.pref. Otherwise, it's a.size plus b.pref. And then suff is pretty much the same thing. Um, and then max one, I'd use new max one over here. Min is new min one, and size. The new size is just both of them combined together. So a.size plus b.size. So look at new max one, right? So first I set new max one to a dot max one. If b dot max one is greater than or equal to 0, which means b dot max one is this, then you set this to b dot max one plus a dot size, right? Because it's greater. And then for new max one, new min one, first I set it to b dot min one plus a dot size, and then with a dot min one less than a dot size, which means a dot min one exists, then new min one will just be equal to a dot min one, right? Um, so this is new max one and new min one. So now the key thing is just finding answer. So first of all, new answer should be A dot answer plus B dot answer. It should be the original answers added together. And then uh the only way we can add values is we have the L ranging A and the R ranging B. And then we add L and L and R works, and then we add 1 to our answer. So how many of these are there, right? Basically, just kind of a included exclusion, maybe. I add and then I subtract if there are overlap. So first of all, if A has a greatest one value, then everything before that one value can use that, right? For example, if we have 0, 1, 0, 0, right? We can pick this 0 and we can change it 0, 1, and 0, 0. We can choose the 0 and we can pair it with this 0 or this one. All right, both works. So new answer plus equal to 1 long long times A dot max 1, right? Max 1 is 1, so there's 1 above it we can choose, and B dot size. Anything in B we can also choose. And then same thing with B. If B dot min 1 is less than B dot size, which means B dot min 1 exists, then new answer plus equal to 1 long long times A dot size, and B dot size minus B dot min 1 minus 1. And then if there are any overlaps, for example, 0, 1, 1, 0, then you can just subtract the overlap. Let's just walk over it, right? If it's 0, 1, and 1, 0, first we added 0 and 1, and we added 0 and 0. We also added this 0 and 0 and 1 and 0. You'll see the 0 and 0 overlapped. So we subtract 0 and 0. We subtract A dot max 1 times B dot size minus B dot min 1 minus 1. Right? That would be the overlap part. Because if we choose something over here and something over here, we use both of these ones. So we subtract that. And that's it. That's our new answer. We just return everything. We add a separate method for our info, and then you're done. Right? You just return your answering that. So really nice problem. Yeah. There's a segment tree. I haven't seen a segment. I haven't done a segment tree on Leetcode in a long time, but yeah. All right. So that's it. This is Leetcode Weekly Contest 514. See all of you guys next time.